Assalamualaikum. We are from Group 1 and our educational video is about smart city in transportation. So let me introduce our team members first. The first one is our project manager.
Hi, my name is Nurfarani Nafitri.
I am Nordami Afrina binti Zubaidi.
And I am Izzatina Soha binti Salihuddin.
So let me introduce you to smart city. A smart city uses variety of technology and infrastructure such as software, hardware, user interface, and data management to improve community quality of life and enable economic growth through network. This structure can include anything from transportation to home usage and on-street sensors. So what is actually smart city? According to Shea and Burns, smart city is a municipality that uses information and communication technologies to increase operational efficiency, share information with the public, and improve both the quality of government services and citizen welfare. For the history, Shea and Burns 2020 stated that in 1960s and 1970s, the idea of smart city was traced back when the Community Analysis Bureau started using the database system, analysis and infrared area photography to collect data, issue reports, and direct resources. These are the applications of smart city that we found based on our research. The first one is smart road. Smart city uses smart roads such as smart lampposts, smart traffic light on roads. It is yet to be used widely, but there are countries that are using smart roads such as in China. Next is biometric authentication. The system creates a convenient way to access applications and devices. People are familiar with face recognition, biometric fingerprints, and sensors, but this system can also detect how much pressure someone applies the button and how fast that person types and more.
Next, the application of smart city includes EV charging. In a smart city, EV charging infrastructure provides convenient, accessible charging stations that support electric vehicle adoption and reduce emission. Integrated with real-time data and dynamic pricing, these stations optimize energy use and align with smart city goals for sustainable, efficient urban mobility. And lastly, we include smart parking. In a smart city, smart parking systems with LED, red, and green lights indicate real-time parking availability, helping drivers quickly locate open spaces. This reduces traffic congestion, lowers emission, and enhances efficiency of urban mobility.
So these are the 7 IT infrastructure components that we must know to help us decide what we actually need to fulfill our business goals. There are computer hardware, software platform, data management, operating system, network or telecommunication, internet and consulting system information. So let me introduce you to the IT infrastructure for each application that we've mentioned just now. The first one, smart road, which are smart lampposts and smart traffic light. From the first aspect, computer hardware, smart lampposts equipped with hardware components such as LED lighting modules, cameras, as well as environmental sensors. According to Philips themselves, a Dutch multinational conglomerate corporation, they use Philips CT Touch system that uses smart LED lights alongside sensors to adjust brightness. This is done based on real-time lighting conditions to reduce energy consumption when the streets are empty. For smart traffic light, hardware involved is vehicle detection sensors, which is radar or LiDAR. For example, My Vision's traffic link system that detects traffic volumes and modifies signal timing by using cameras and processors inside the traffic lights. Next is software platform. Smart lamppost. As per Ubiware said, its platform allows remote control and monitoring of lighting. For example, Talensa's Planet platform that regulates street lighting according to data that was collected. Smart traffic light. For example, Siemens Sea Traffic Concept, a traffic management platform that enables cities to dynamically control and synchronize traffic signals. Next is data management. For smart lampposts, all data are stored and analyzed to optimize performance. GE's current entry platform monitor energy consumption, spot lamp outages, and analyze environmental conditions by using collected data. For smart traffic light, it is used to allow long-term improvements by collecting and storing traffic data to track flow patterns. For example, InReach Traffic analyzes data from smart traffic lights and vehicles. Next is OS, operating system. Smart lampposts, as per Dr. Max said, they operate using Linux-based OS like embedded Linux to provide reliable operation for IoT devices. It controls sensors and communication functions. For smart traffic light, it uses real-time systems that prioritize immediate response for changing light signals. For example, QNX, which is a commercial Unix-like real-time OS. Next is network telecom. Smart lampposts connected through wireless networks, LoRaWAN 5G, in order to transmit data on light usage, device health, and environmental conditions to central control center. For smart traffic light, it uses vehicle to infrastructure (V2I) technology to communicate with vehicles. For example, Audi's traffic light information system that connects with V2I. Next is internet. Smart lampposts allow remote monitoring and management, allowing cities to adjust light levels based on traffic conditions and reduce energy usage during off-peak hours. For smart traffic light, it connects it to centralized systems and other intersections to enable real-time adjustments across the network. It can also alert drivers about delays or hazards. Next is consulting system information. For smart lampposts, consulting teams analyze data then advise on strategy to save energy to improve lighting efficiency. For smart traffic light, consulting teams help cities design this efficient system by analyzing traffic data as well as optimizing signal timing. Moving on to the next one, biometric authentication. For computer hardware, biometric scanners and sensors. Hardware used has devices that capture biometric data, such as fingerprint scanners, facial recognition, and iris scanners. These devices can be integrated into computers, smartphones, and access control systems. For example, Apple's iPhone, which is Touch ID and Face ID. Next is software platform. Integration platforms. Some software platforms integrate with other security systems to access control. For example, Windows Hello, Microsoft's biometric sign-in feature. These are for secure access to devices and applications. Next is data management, storage and retrieval. Data is stored in encrypted databases. Any attention will be compared against stored templates in real time. For example, bank's biometric authentication system for mobile banking to protect customer data. For OS, we have biometrics API and drivers. OS may include this to enable developers to integrate biometric authentication features into applications securely. For example, Android's operating system has it where it enables app developers to integrate fingerprint and facial recognition, such as application login and payment authentication. In terms of network and telecommunication, it uses remote authentication, where it allows central servers to authenticate users accessing resources from various locations. A company with offices all across the world might use a secure VPN or private network to transmit biometric data to central authentication server, for example. And we have internet. It uses real-time feature, which is the most important feature for online applications, such as banking, e-commerce. We can take Shopee, TikTok as an example, where they provide a cloud-based biometric authentication API so developers can use to add fingerprint or facial recognition features. Consulting system information. Consulting for system design and implementation, where consultants help design and deploy biometric systems. They ensure the system meets business requirements and standards.
In EV charging, computer hardware used are EV charging station, where there are the physical station equipped with charging connectors and built-in controllers to monitor and manage charging session. Next is embedded sensors and meters. Sensors monitor charging process, energy consumption, and environmental data, while meters track energy usage for billing purpose. Next is display panels and interfaces. Screens at the station display charging information, instructions, and pricing details. Lastly, in computer hardware use is user devices. Mobile devices like smartphones allows user to access EV charging apps for locating station, managing payment, and receiving charging status notification. Next, we will see in software platform, where data analytics software is used. Analyze charging station usage, identifies peak times, and manage energy loads. This can also be used for predictive maintenance of charging equipment. Next is mobile application, provides user with real-time information on charger availability, charging progress, and reservation option payment processing. Next, we will see in data management, where database system like PostgreSQL, MySQL, or NoSQL solutions store data on charging session, user accounts, energy consumption, and billing records. Next is data warehousing and big data, used for storing and analyzing large volumes of data generated by charging stations. Next, we will see in operating system, where server OS, such as cloud or on-premises setups, may run in Linux or Windows servers, optimized for managing charging data and handling network traffic. Next is network or telecom, 4G or 5G networks. It supports real-time data exchange between charging station and mobile application, enabling remote management and monitoring. Ethernet fiber optic provides high-speed data transfer for charging hubs or areas with multiple charging stations, allowing fast, reliable data synchronization. Internet, where real-time data streaming is important, protocols like MQTT or WebSockets support real-time data streaming between EV stations, mobile apps, and centralized management systems. Cloud services manage charging session, data monitors energy usage, and support dynamic pricing model. Lastly is consulting and system integration of EV charging, such as IT consultation, like specialists in EV infrastructure, help in designing and deploying charging networks, managing scalability, and ensuring security and compliance. And then we have system integration services. Integrators ensure smooth connectivity between EV charging station, cloud platforms, payment system, and smart city data system. And lastly, we have smart parking that includes in our smart city. We will see in computer hardware, we have sensors, ultrasonic, infrared, or magnetic sensor installed in each parking spot to detect the presence of a vehicle. Next is indicator lights, where red and green LED installed above each parking spots. Next, we will see in software platform, where back-end application processes sensor data, integrates with the database, and interfaces with the user application. We also have IoT platform. This manages IoT devices, enable data gathering, and ensure communication between sensor, lights, and central services. The example includes AWS IoT Core, Google IoT, or IBM Watson IoT. Next is data management. Database systems such as like cloud-based or premises database store information on parking spots, user data, and sensor data. And we will see in data warehousing and big data used for analyzing large data sets to identify trends in parking demands or optimize infrastructure. Next is operating system, embedded OS for IoT devices. IoT devices often use lightweight operating system like FreeROT OS, Contiki, or Linux to manage the sensors. Next is network or telecommunication, where Ethernet or fiber optic is used for high-speed data transfer between local servers and cloud storage or within a centralized data processing facility. Next, we will see in internet terms, where cloud providers like Blackblaze, CloudSpace, and Google Cloud offer infrastructure for storage, computing power, data processing, artificial intelligence, or machine learning services. Lastly, we will see in consulting system integration. IT consultants It helps in developing the smart parking strategy from requirement gathering to infrastructure design. System integration services integrate various components from IoT devices to cloud database, ensuring seamless interoperability between all EED. Lastly, we will see in maintenance and support. Manage services and ongoing support for troubleshooting system updates and improvement if any damage sensor occurs.
Okay, next we move to the parts of benefit of smart city in transportation. There are 4 benefits that we have studied, which are reduce traffic congestion, which is a smart traffic management use data from sensor and GPS device. This traffic light management system can optimize traffic flow, reduce delay, and help improve traffic flows. Number 2, enhance safety and security. Smart city technology enables real-time monitoring and proactive measures to ensure public safety. Also, the third is parking solution, where technology such as sensors-based parking help drive find available parking spot quickly and detect the taken slots. Lastly, better travel planning. By utilizing real-time data and advanced planning tools, smart mobility enables users to better organize their travels. It provides information on schedules, traffic conditions, transport options, and alternatives.
For conclusion, smart city transportation initiatives like smart roads, biometric authentication, smart parking, and EV charging enhance urban mobility by making it safer, more efficient, and sustainable. Smart roads optimize traffic flow while biometric authentication secure and personalized transit experience. Smart parking and EV charging reduce congestion and support eco-friendly travel, contributing to a connected urban ecosystem that improves quality of life and adapts to future needs.
Next, we go to Q&A session. The first question is, how does smart road work? Smart roads are the road created forward with sensors, cameras, and connected with advanced technology. It communicates with vehicle, traffic light, people movement that provide real-time information that can improve traffic flow. Number 2, how do smart lampposts and smart traffic light contribute to smart roads? Smart lampposts and traffic light have communication capability that can detect presence and adjust lighting or signal timing based on real-time traffic. They reduce energy consumption and improve road safety. The third one, why biometric technology are used in transportation? According to Sharman, biometric security is integrated into smart transportation system for secure access to public transportation service. Some biometric security technology like facial recognition and fingerprint authentication facilitate contactless and secure boarding, preventing unauthorized use of public transit service.
So how does EV charge infrastructure support smart cities? EV are important for supporting electric vehicles, where the system can reduce air pollution. By integrating electric chargers, cities can manage waste of energy and provide drivers with easy access to charging stations. What is the role of cloud computing in transportation? Cloud computing is good for development in smart city. By accessing traffic data, GPS tracking, and real-time updates, cloud-based platforms empower cities to efficiently monitor and manage flow systems. What are the examples of data security measures? Data security measures such as data encryption, software updates, and multi-factor authentication for access control. Encryption and tokenization that use can help protect user privacy by ensuring sensitive confidential is not stored immediately in the system. For the last question, can smart parking systems support multi-level parking structures? Yes, smart parking systems use sensors placed at each parking spot to detect presence. These sensors can be installed on multi-level structures and integrated with apps that provide drivers with available parking information, including specific levels or zones. So that is all from us. Thank you for watching.